Hi, everyone. So it turns out my whole family is now sick, which means that I have little kids, very upset and not feeling well. My husband has just taken them out for a quick car ride, hopefully in between being sick, literally being sick. So obviously they're not in school, and recording a lecture just got a lot harder. Luckily, I went back and watched through last year's video for this lecture, and it's really, really good, and I think it's the right one. There's some comments at the end about how I restructured the course. I planned for that this year. Last year, I found this lecture, what I was going to do, was overwhelming. So I restructured a little bit and broke it into method of sections trusses for this lecture and method of sections beams for next week. So this week is just method of sections trusses. So I've already posted that link. I'll send it. It's coming out into an announcement for you guys. I wanted to. A couple people at the end of last week talked about how the right hand rule freaked them out and they didn't understand how to apply it. And I don't like to brush people off. Normally, people, when they practice it, get it, but somebody seemed really adamant that they were never going to get it. So I just wanted to make a quick video to maybe help that person out, and maybe this will benefit other people on how you apply the right hand rule. So we said that if this is your right hand, you can use it to represent any direction. And the direction your fingers curl in is the direction it's trying to spin, and then your thumb tells you if it's positive or negative. And so if I have something spinning in this direction with my right hand and I point my thumb, that's telling me it's a positive moment. If I have something spinning in that direction and my thumb is pointing down, that means it's a negative moment about the z-axis or the y-axis. Remember, we said this is our x-axis, this is our y-axis, and in and out of the page is our z-axis. So spinning about the y-axis, positive. Spinning about the y-axis, negative. Now, I think what confused people is when I was talking about trying to spin an object about a point, and people couldn't get their head around it. So what I've done is I've created a little green arrow and a piece of cardboard, and we're going to move it around in a few spots and take a look at that. So let me just tip my screen down, and we've got this beam here, some imaginary beam, and it's a pin support, so it's not great. We know it's not stable in all the directions, but we just want to talk about moment right now, and we have a force. So imagine this is our imaginary thumbtack that we're going to pick somewhere that we can put it. If I put it right here, and I put my arrow here, we're saying that we have a thumbtack right here, and this, I'm going to push in that direction. See, it's pushing upwards, but it's got distance from the support, so it's making it spin. If I curled my right hand in that direction that it's trying to make it spin, and point my thumb, it is trying to spin this in the positive direction about this point right here. What if I moved my arrow to right here? Imaginary thumbtack, still trying to make it spin in the same direction. We've got a smaller eccentricity, so it's probably a smaller moment, but we're just trying to talk about positive and negative moments right now. Now, for those of you that this might help, if you wanted to think about it this way, we know it's spinning in this direction, which is counterclockwise. In this world that we talk about forces, counterclockwise is positive and clockwise is negative. So thumbtack, fingers curled, thumb up, that's positive. It's trying to spin it counterclockwise, so the positive direction. What if, with this force still right here, I moved my imaginary thumbtack to this side? Put my imaginary thumbtack right here. If I physically push in that direction of that arrow, you can see it tries to spin it in that direction. I'm using my right hand. My thumb points downwards. You could also see that this is clockwise. So about this point right here, this exact same force in the exact same spot on the beam is now trying to spin it in a negative direction. So it depends what point you're spinning about and where the force is, whether it's positive or negative. So that is a handy trick to do. Physically do it with your paper if you're having a hard time doing it. So I just wanted to, oh, that's awkward. I just wanted to mention that just because I didn't want those people to feel abandoned. So I wanted to kind of give all the extra little help I could. You could probably find other videos. Maybe you don't like the sound of my voice. I'm sure if you look up right hand rule, static equilibrium, you will find other videos that maybe explain it better than I do. I think the best way to do it is practice. Literally put your finger where your imaginary pin is. It might be where the actual pin is on a member. And then push your paper in the direction that the arrow is trying to move it, and you will see what direction your paper is trying to spin. And if it's easier, you can think as counterclockwise as positive and clockwise as negative. And so that might help some of you if that gets your head around it a bit easier. Another way to help remember it, well, I think that might just confuse people. I was going to talk about a globe, but I think that might just confuse people a little bit. So again, I'm sorry that I am sick this week and that I can't record the lecture. Next week I'll be recording the lecture, but hopefully I'll be able to do it without the kids home and have it posted for you guys before the lecture time next week. So I went back, I looked at that video from last year. It's great, and I think you guys are going to find it helpful, especially where it is almost all equation based or work on paper. And so it's very nice and neat with color-coded pens. I think you might appreciate that for this one, for this week's lecture. So I will be posting next week's lecture, and I will see you guys in person in 2 weeks. Bye.